All right, so on number 1, they're showing you a quadratic graph, and they want to know if it's extended from -1 to 6, right? So from -1 to 6, what would the y value be when x equals 2? So what do we know about quadratics? What do we know about parallel? What do we know about the parabola? It's symmetrical, right? Meaning, when I cut it in half, whatever's on this side should be up the exact same on this side, right? So here, this is 1 away and they have the same y value. So this one's 2 away. So if it's 2 away, it should have the same value as that one, right? This down here is 1, 2, 3, 4 away. So 1, 2, 3, 4 right there. This one over here, 1, 2, 3, 4, 5, 6 away. So 1, 2, 3, 4, 5, 6. Okay, so if your parabola was extended, it'd look like that. But what they want to know is what the y value is when x equals 2. X equals 2 right here, so my y value would be 1. So f of 2 would be 1. Does that make sense? It's either like that or y equals 1. Okay, so number 2. So you have to create 3 different equations for those types of functions. So for a linear function, in order for it to be increasing, your slope has to be positive, right? So y equals 2x is an example. I think I gave that to y'all yesterday. So if increasing is a positive slope, what is decreasing?
Negative.
So that would be a negative slope. And if it's vertical, what should it be? X equals any number, right? Poivux. Horizontal, which is like that, is 0 slope, and so it'd be y equals. Vertical, that's an undefined slope, and so that would be x equals. No, what's wrong? Because they want the equation, right? The equation of a line. They're not asking for the slope. So quadratic function, we talked about, opens up is like this, and that's when a is what? A is positive, right? So y equals 2x squared would be an example. As long as the number in front of the x squared is positive. So opens down means the coefficient of x squared is negative. So y equals negative 2x squared. Then has a vertex of 0, 5. So what did we talk about when b is 0, right? It's BC. When b is 0, then your vertex is BC, right? And now if our function is ax squared plus bx plus c, I didn't say anything about opening up or down. So a could be whatever, but for sure b has to be 0 and c has to be 5. 0 is just 0, so I don't have to write the 0. So an example would be 2x squared plus 5. That makes sense? It has to have the x squared plus 5. You can have whatever number in front of the x squared, but the plus 5 has to be there. Okay? Exponential functions, what does that look like? Y equals AB raised to the x. What does A stand for? Initial, you're starting, your original value, right? B is, it tells you if it's increasing or decreasing, or if it's growth or decay. If it's greater than 1, then it's what? Growth. If it's less than 1, decay, all right? So an example of growth would be 2 times 3 raised to the x. Decay has to be less than 1, so 1/2 raised to the x. Sometimes they'll put it as fractions or decimals. Okay? Any questions about that? So remember, this is multiple choice. Okay? I just wanted you to do this pre-response style because I made it harder, so that way if you can do this, you should be able to do the test. Alright, Deshaun threw a football into the air. The function h of t equals, wow, I screwed that up. Those should be t's, not x's. H of t equals negative x squared plus 16x plus 6 can be used to determine the height h of the football after t seconds. What is the maximum height the football reached? Okay, so this is a quadratic function, right? And whenever you see the word maximum, what does that have to deal with? What is it called? The vertex, right? How can I figure out what the vertex is from the equation? So this gives me the axis of symmetry, right? The axis of symmetry tells me what the x value is of my vertex, right? In this problem, what does the x value of the vertex tell me? Seconds what? Like in the situation, what does the x value of the vertex mean? Think about it. What about the y value? What's the y value of the vertex? No, I'm just talking about in general, like whatever the number is, what does it mean? In context of the problem, what does it mean? What about the height? The maximum height, right? So the y value of the vertex is the maximum height. What is the x? The time it happened, right? Okay, if you're saying just seconds, it's seconds, but what I was looking for is the x value stands for when it reached its maximum height. Does that make sense? Okay, so now that's what I'm trying to figure out, when it happened. So that when I figure out when it happened, if I plug it into this equation, it'll tell me what the height was. Okay, so what is A? -1, B, and I don't need C. So negative B, so it's -16 divided by 2 times -1. So it gives me -16 divided by -2, which is +8, right? So that means after 8 seconds, that's when it reached its maximum height. Okay? So h of 8 is -8 squared plus 16 times 8 plus 6. So 8 squared is what? -64. And then you have to, okay, but some people don't know it. Okay? So if you have to do this, don't be embarrassed. I have to do it. I don't know what 16 times 8 is. Okay? 48, right? See? 128. Okay? 64 is half of 128. So this becomes 64 plus 6. So your answer is 70. Okay? So the maximum height is 70 feet, I guess. Yeah. Any questions about that? All right, this is exactly like one of your homeworks. Remember? The one that most of y'all didn't do? Exact questions like this. The only difference is they talked about in the real world. If he threw it this high, well, how high does it reach? Does that make sense? But this process right here is the exact same as what y'all did, what y'all should have done on that homework. Okay, Juan lives 2 kilometers from school. There are 2 stoplights on the straight road between his house and the school. One morning, Juan leaves home, walks at a constant rate to the first stoplight, waits to cross the road, and then continues to the next stoplight. He stops and then crosses the road and goes to school. He stops to talk to his friends when he arrives. Realizing that he left his homework at home, he walks back home. As he walks towards home, he does not have to wait to cross the road at both stoplights. Alright? Based on the information and the distance time graph showing Juan's distance from home at a given time, provide the time intervals for the following situations. Okay, what does the x-axis stand for? Time, right? And it's minutes. What about the y? Distance. We are dealing with a distance graph, right? And it's in kilometers. Okay? So now they're talking about when is Juan walking the fastest. How do you figure out how fast someone is walking? But I'm talking about how do you figure out how fast someone is talking? How fast someone is walking, sorry. How do you figure that out?
How much distance it did
right? How much distance he traveled in that amount of time, right? So you did distance divided by time. So here, distance divided by time would be your slope. Y divided by x, the change in y divided by the change in x, the change of the distance divided by the change in time, that's your slope, right? So all you have to do is figure out what the slope is. So here my slope is 0.2. This one's 0 slope. This one's 0.3. 0, 0.2, 0, 0.2, and this one's 0.8 divided by 3, right? Which equals 0.266666, repeat. So when is Juan walking the fastest? What is the fastest speed that he reaches? 0.3, right? So it's twice that he does that. So the fastest, the fastest would be from here to here and then here to here, right? You have to include both, okay? Because they're both he's traveling the same speed at both of those intervals. So it would be from 6 to 8, right?
Yeah.
8 or 9?
8, 9.
So this is 1, 2, 3, 4, 5, 6, 7, 8. It's 8.
Oh, okay.
6 to 8. And then 8, 9.
Wait, they're not equal.
14, 16. So 6 to 8 and 14 to 16. That is when he's walking the fastest.
Wait, why is he going like that?
Got it? When is he walking the slowest? 0.2, right? So that's from 0 to 1, 2, 3, 4. And then 9 to 12. Josh? 13, 14, 16 to 19. Okay, so 0 to 4, 9 to 12, and 16 to 19. That is when he's walking the slowest. Okay, can't use 0 because he's not walking. He's not walking, he's just standing still. Okay, what was the maximum distance he reached from his house? 2 kilometers, right? The maximum is 2 kilometers. Make sure you include your units. How many different speeds did Juan walk? What are the time intervals of those
4
speeds?
different speeds.
3.
3 different speeds.
0.2, 0.26 repeating, and 0.3. Right? We already did what the 0.3 was. The 0.26, 0.2 is this one. Alright, so this one would go here. This one down here. 0.26 would be from 19 to 22. That makes sense? Right, we already did the 0.2, that's the slowest. 0.3 is the fastest. So the only one we haven't done was the middle.
What is the one that's what's the second one?
0.26,
Yeah.
19 to 22.
What's the last one?
0.3. How do you get it? So slope. So from here it's 0.2 and then 1. Up here it's, I'm going to do it the opposite way. So I go over 2, so my run is 2, and then I go up 2, 4, 6. 0.6. 0.6 divided by 2 is 0.3. Okay?
How'd you get 0.26?
If you divide 3 into 8, 0.8, it goes twice, that's 6. 3 goes into 26 times, that's 18, and then it's going to keep on repeating. Okay, the number on the test is going to be prettier.
Really?
Yeah.
It's ugly.
That's ugly. That's considered ugly because it's not perfect. Keeps repeating. Well, they're all rational. No, they're all rational. Because they're a fraction. Okay. Alright. What kind of graph am I looking at?
We're looking at a speed graph.
Speed. This is speed. This is not distance, right? This is speed. Okay, Lana the ladybug crossed along a garden fence during a 12-second time interval. That's supposed to be 14. Her speed in centimeters per second is shown on the graph. Use the graph to answer the following questions. Okay, what is Lana's maximum speed? 10 centimeters per second. Okay, speed is centimeters per second. Seconds are time. Alright, on what time interval is Lana's speed increasing? 0 what? 0 to 3, right? Increasing means what? Positive slope, right? So 0 to 3, 5 to 7. Yes. 8 to 11. And then 13 to 14.
How come they have the light under?
I don't know, like what makes, like, how do you know if it's
Well, I
gonna
know
have
what
it
makes it
under?
have the light under, but I don't see how. And the other one is going to happen.
It doesn't matter. There's well, actually here, when it's talking about increasing or decreasing, I mean, it doesn't matter because, so there's a big debate in the math world talking about if it should be including or not included. Some people prefer to include it, some people prefer to not include it. People like, they're not going to count you wrong for that.
But what if they have the same thing, but one is with the line and one's not?
They won't.
Okay, good.
Okay. No, they won't. I don't think so. Let me go check it out. I'll tell you.
Oh yeah, that's sorry.
Okay, how many times did she reach a speed of 3 centimeters per second? How many times did she reach 3 centimeters per second?
4.
Let's do. Okay, so 3 centimeters per second is the y value. So 3 is right here. So it happened once, twice, 3 times, 4 times, 5 times. She reached a speed of 3 centimeters per second 5 times. Okay, 6 centimeters per second. So that's 1, 2, 3, 4.
Sure? Oh, yeah.
Positive. 9 centimeters. So that's once right here, twice, 3 times. And then 9.5 would be, 9.5 is right here. 1, 2. 2 times. Does that make sense?
Yes.
Some people wanted to find the slope of each of them and see if the slope, right. You have to pay attention to what kind of graph you're dealing with. If it's a speed, then the slope is acceleration. Okay, if it's a distance graph, then your slope is speed. Does that make sense? That's a little confusing. Well, your slope is velocity, but your absolute value slope is speed. Your distance graph, that's your slope of that graph is going to be your speed / velocity. Your speed graph, the slope of that's going to be acceleration, right? Okay, this one's your free response. This one's not going to have multiple choice. Okay? So Daniel rides his bicycle along a straight road starting from home at t = 0 minutes. For the first 8 minutes, Daniel's speed in miles per minute is modeled by the piecewise linear function whose graph is provided. And they even give you tables. How fast is Daniel riding when t = 1 minute? Include units and the answers. So what kind of a graph am I dealing with?
Dealing with the speed.
Speed. So what is y? What is my y value? Which is speed, right? Your y value is speed. So basically they're asking, what is the y value when t = 1?
It's 0.45.
T = 1, right there, point, is it 0.45? I don't know. 0.15.
Oh, 0.45.
0.15. I know they're hard to see. It's going to be easier to see on the test.
Exactly.
So it's 0.15 miles per minute. Okay, what is the equation for Daniel's speed between 0 and 2 minutes?
So what do you do?
Why would it be 0.3?
It's an equation, not like an answer.
What is the equation? Yeah, I have to do that. How do you write the equation of this line right here?
Is it exactly mx?
Why not?
Exactly.
Why can I use y = mx + b? No, why can I? Like, you can use y = mx + b, but why? It's a linear, but what else? You know your slope. What else do you know? Y what? What's the y-intercept? It starts at 0, right? 0, 0. So meaning my y-intercept is 0, so b is what? 0. So I just need my m. Now what's my m?
Your m, which is your slope, is
3.
Oh, no.
Some people would say
3, 4, 5,
3 over 1, right?
6 over 2.
But what is the y going by?
0.5.
0.5, 0.05, right? 0.05, 0.1, 0.15. We just talked about it right here. Right? 0.15 t. That's the equation of that line.
Oh, you don't have to put plus or.
Because it's 0.
Is it 0.15 or 0.05?
It's 0.15. Because think about it. If I plug in 1, I should get 0.15, right? So 1, 0.15. If I plug in 2, what should I get? What's 15 times 2? 30, right? So 0.3. So 2 is at 0.3. Does that make sense?
Yeah.
No, because they're telling you it's between 0 and 2 minutes. If they told you to write the equation of the piecewise function, that's when you would have to do it's between 0 and 2.
So that's if you're finding a piecewise?
So for the whole thing, yeah.
Okay.
But since they tell you what's the equation between 0 and 2, you don't have to do it. They just want to know what the equation of that line is. Okay, so the next one is 5 and 6.
Okay, so 5 and 6, that's equals,
Does that say 0.5?
Y equals 0.15.
S equals 0.52.
So S equals 0.45 t, is that what you're saying? So if I plug in 5 here, it's going to give me 0. You need the y-intercept. Do you know what the y-intercept is? No. You do not know what the y-intercept is. That one you cannot do y equals mx plus b. Which one is the best way to do it?
Y1 or not? Alright.
Y minus y1 equals m times x minus x1. Right? You need a point and a slope. Right? What's my slope?
The slope is
Y'all had the slope right, 0.45.
Okay.
Right? Because it goes up 0.45 over 1. So that was right. Now you just need a point. Let's do 5, 0.
Yeah.
Right? 5, 0. This is a point. Okay, so it's y minus y1, which is 0.
Equals 0.45 with parentheses x minus 5.
So my equation would be s equals 0.45 parentheses t minus 5.
Where how did you do
5, 0 is a point on the graph. On that line. Make sense? Sure?
X minus. Is that a t or an x?
I put t because it's time and speed. Like if you do this off to the side, that's fine, but whenever you're actually writing the answer, you're dealing with speed and time. Okay, the equation for Daniel's speed between 7 and 8 minutes is s equals negative 0.2 times t minus 7 plus 0.45, where s, the speed in miles per minute, is, and t is the time in minutes. That's terrible. How fast is Daniel writing when t equals 7.3 minutes? So what do I have to do? Into what?
Point slope.
Into that equation they give you, right?
Wait, but how would you? Okay, do it.
So s equals negative 0.2 t minus 7 plus 0.45, right? And they say, what is the speed when t is 7.3? So where t is, I'm going to put 7.3. So s becomes negative 0.2 times 7.3 minus 7 plus 0.45. And so there it just becomes a math problem. 7.3 minus 7 is what? 0.3. plus 0.45. And then 0.2 times 0.3. 0.0.
Minus negative.
Negative 0.06. And then plus 0.45. So 0.39. Whoa. Said one thing, wrote the other. 0.39, right? So this one's negative, this one's positive. So bigger number minus the smaller number. So 0.45 minus 0.06 would be 0.39. Right? And then you keep the sign of the bigger number, it's positive. So the speed is 0.39 miles per minute. So 0.39 miles per minute. Yes.
You would have distributed, would you still get the same answer?
Yeah. Since the area between the speed function and the t-axis represents the distance that Daniel travels, how far does Daniel ride during the first 4 minutes? Include units in the answer. Okay, so what they're saying is, of a speed graph, when you find the area between the graph and the t-axis, that'll tell you how much distance he traveled, right? So I want to find the area under this triangle, right, from 0 to 4, right? You all remember when we did this?
Yeah.
Okay, so the area of triangle is what?
1/3 pH or 1/2 pH.
1/2 pH. Remember, the reason it's half is because a triangle is half a square, right? If you take the area of a square and you cut that in half, you have the triangle. Does that make sense?
Yeah.
Okay, let's draw it. I have a square.
Oh yeah.
Okay, this is the length, this is the width, right? What is the area of this square?
The
Length times width, right? Or base times height. Okay, now if I cut this in half, what do I have?
Half of a triangle.
No, you don't have half a
Oh,
triangle.
one
You have two
triangle.
triangles, right? So the area of one of those triangles is half the length times the width, which is why the area of the triangle is 1/2 base times height. Okay, does that make sense? So if anything, remember that the area of a triangle is half the area of a square.
What is it? 1/3 pH.
I don't, maybe a cone. That's next. That's next. That's next year. That's next year. No, I was trying to think because I don't remember. That's geometry. No, that's next year. Or in the summer. In the summer. Okay, so what's the base?
The base is 4.
4. What is the height?
The height is 0.3.
So I want 1/2 4 times 0.3. So half of 4 is what?
2.
2 times 0.3, which is what?
Yeah.
So 0.6. But what does that mean?
That's how much you roll.
Yeah, that's what he traveled.
That's how much he traveled, right? He rode 0.6 miles.
Per minute.
No,
Or
it's just distance.
already.
Because think about it, right? 0.3 is what? What is 0.3? The speed, which is miles per minute, right? So miles per minute. And then we multiplied by 4. What does 4 stand for? Minutes, right? What can I do? The minutes cancel out, right? So I should end up with miles. That's why when you multiply speed times time, it gives you the distance. So 0.6 miles. Okay? That makes sense? Here, all you're doing is finding the area of that triangle and then adding miles to the end of it. Okay? Daniel decreased his speed at a constant rate from t equals 8 minutes to t equals 11 minutes, so that his speed at t equals 11 minutes will be 0 miles per minute. On the graph provided, extend the speed function to include this new information. Mark each grid point that lies on the new portion of the speed function. How much farther will Daniel travel in this time period? Okay, so they're saying at 11 it should be 0. So that's how much he traveled, and they want you to draw this. I don't know why, but just do it. So it should look like that. That's the mark each grid point that lies on the new portion of the speed function. And then how much farther will Daniel travel in this time period? So now they're asking for distance. How do I figure that out?
Distance time.
Speed over.
Speed over.
Time.
Yeah. You're just finding the area again, right?
Okay.
Because we found the distance here. So if I want to find the distance he traveled, how much more he traveled here, I just need to find the area of this triangle right here. Okay? So if you find the area of that triangle, 1/2 base times height again.
3. Oh.
So my base is 3, right?
And then time 0.25? No, point what?
Yeah, 0.25. Okay, this one here you're gonna actually, yeah, 1/2. 3/4 is how much?
75.
75 cents, right? So now I need to divide 70.75 cents divided by 2. So 2.75. 2 into 7 goes 3 times. That's 6. 15. That's 7 times for 14. 1, 0. Bring it down to 0. So that's 5. So 0.375 miles. So that's how much further he travels. Okay? So that one you're finding the area of the curve again from 8 to 11.
Also, you times 3 and 0.25 first.
Yeah, that's what I did that one first because I don't know what half of 3 is.
Okay.
Well, I mean, it's
Well, you
1.5.
can multiply 1/2 times 3.
Hmm?
Did you do that?
Yeah. Whichever order you prefer.
Will we get points taken off if we don't add the money?
Huh?
Will we get points taken off if we don't add the money?
Yes, you have to include your units. You have to include your units. Okay? And they're asking for distance, right? So your distance is miles. Okay? Just look what the question is asking for.
So if it asks for times, what would it be?
If it asks for time, it should be minutes.
Okay.
If it asks for distance, it should be miles. If it asks for speed, it should be miles per minute. Right? It all depends on the graph. Okay, any questions?
No, sir.
Okay, good.